Hi, good day everyone. This video is about the integral zeros of the polynomial function. Again, according to the concept of polynomial function, zeros are also known as the solution that will satisfy our given expression. So for example, let's try to answer this given problem. Say we are asked to solve or find the zeros of this given polynomial, which is equals to x cubed minus x squared minus 10x minus 8. So to solve for the zeros of this given polynomial, we have this set of steps. So for step number 1 is we need to simply list all of the possible integral zeros of p of x. Again, we need to list all of the possible integral zeros. That means to solve for the possible integral zeros, we simply need to list down all of the divisors or factors of our constant. So for this problem, we have this given constant as negative 8. So we have negative 8. That means we simply need to list down its possible factors or divisors. Right? So let's try to list them. Again, if we have negative 8, I think this is a product of negative 8 times positive 1 or 8 times negative 1. Okay? It is also a product of negative 4 times 2, and also it is a product of 4 times negative 2. Okay, so we have this set of factors for this given value, which is negative 8. Our next step is to simply list down all of the values or the numbers we obtain. So we have 1, we also have 2, we have 4, and we have 8. Right? Since we have this list of divisors, don't forget to also include its negative value. So that means for step number 1, always include its positive and negative sign. That means we have this positive and negative 1, positive and negative 2, positive and negative 4, and positive and negative 8. So that is our step number 1, the list of all possible integral zeros of this given polynomial. So let's proceed to step number 2. So for step number 2 is we need to use synthetic division or evaluation to find at least one zero, right, from among the divisors. That means we need to choose at least one value, right? So it's either positive 1 or negative 1, positive 2 or negative 2, 4 or 8, right? So we need to choose at least one value and try to look for at least one zero. So for this given problem or step, we need to look at least one zero. So for the zeros of this given problem, so let's try to use synthetic division, right? So for example, again, if we have this given problem, we have x cubed minus x squared minus 10x minus 8, right? So since we want to look for at least one zero for this given problem, let's try to choose at least one integral zeros or one possible integral zero. So let's try to use positive and negative 1. Right? So for step number 2, let's try to use x as positive 1 and x as negative 1. Let's try to use synthetic division for this one. Since we want to use synthetic division, that means we need to extract the roots or the coefficients of our given problem. Therefore, it will give us 1 for x cubed, negative 1 for x squared, negative 10 for negative 10x, and negative 8, right, for our constant. Same with our second synthetic division as negative 1. So just copy the values or the given values. 1, negative 1, negative 10, and negative 8. And let's construct a bar. And let's try to use synthetic division to solve this one. So for our first value, we have x as 1. And for second value, we have x as negative 1. If x is equals to 1, therefore it will give us, bring down 1. 1 times 1 is 1. And then add the values. 1 plus negative 1 is 0. 1 times 0 is 0. Negative 10 plus 0 is negative 10. 1 times negative 10 is negative 10. And then add. Negative 8 plus negative 10 is actually equals to negative 18. Since the remainder for this given problem is negative 18. That means this x is equals to 1 is not a 0. Okay? Next, let's try to use x as negative 1. Same procedure. Let's bring down the first number, which is 1. 1 times negative 1 is negative 1. And then add. Negative 1 plus 1 is negative 2. And then multiply it again. Negative 1 times negative 2 is negative 2. Or positive 2. Right? So negative times negative is positive, and then add. Negative 10 plus positive 2 is actually equals to negative 8. And then multiply. Negative 1 times negative 8 is actually positive 8. And then add. Negative 8 plus 8, that is equal to 0. Since the value of our remainder here, for this, or the last number for this given problem, is 0, that means this x as negative 1 is a 0. So this is considered as a 0 of this given polynomial. That means if we have x as negative 1, if you want to convert this expression, right, into a binomial, this x as negative 1 is actually equals to x plus 1, right? So let's try to list, okay, what is the quotient for this given problem. Again, if we have this given solution, this last value will serve as the remainder. We have the constant, we have the first degree term, and then the second degree. Okay, that means the answer for this given problem is we have 1x squared, or x squared, minus 2x raised to 1, or minus 2x, and our constant is negative 8, right? So we have this remainder as 0, so that means we have this final answer for this given division. Okay, that means for this given problem, we have this factor of our original problem. So our original problem is this: we have p of x as x cubed minus x squared minus 10x minus 8. Since we have this value, that means the factor of our previous example is x plus 1 times our quotient, which is x squared minus 2x minus 8. Okay? Since we have this given set of value, so this one will give us x as negative 1, which is the 0 of our problem. Now our next task is to solve for the remaining zeros of this given expression. Okay? So let's try to solve this. So for step number 3, we need to extract the roots. Okay? So we need to solve for the remaining zeros. Right. So to solve for the remaining zeros for this given problem, right, so the remaining zeros, let's try to use factoring for this given problem. Okay? So since we have this x squared minus 2x minus 8, right, and our task is to solve for its zeros, let's try to use factoring. Since we have this given expression, so if we want to factor this one, so it will give us x times another expression. Okay, so we have this technique again for factoring. So just observe the value of our constant. Again, we need to think of two set of values we're in. If you multiply those numbers, it will give us the constant term. And if you add those numbers, it will give us the midterm. That means if we have negative 8 as our constant, maybe negative 8 is a product of negative 8 times 1. Okay? We also have, let's say 4, negative 4 times 2. Right, so let's try to test if we have this set of values. Negative 8 times 1 is, yes, that is negative 8. Right? Next, negative 8 plus 1, the answer is negative 7. So it is not equal to our midterm. That means we need to disqualify these factors. Next, let's say we have negative 4 and positive 2. Right, so let's try to multiply. Negative 4 times positive 2, the answer is negative 8. So good, that is connected to our constant term. Next, negative 4 plus 2, so the answer is negative 2, which is also our midterm. That means the factor for this given problem is negative 4 and positive 2. Right? Since we have this set of factors, that means the roots for this given problem or this given quadratic equation is, so let's construct the table. Again, this t table will separate the value of our first x and the second x. That means if we have this x minus 4, let's equate this to 0, and x plus 2 is equal to 0. Since we have x plus 4 is equal to 0, so let's extract the value of x. So let's add values of 4 both sides. Therefore, x sub 1 is equals to, cancel out, we have positive 4. Okay, next for x plus 2, let's subtract 2 both sides. Okay, therefore it will give us x sub 2 as, cancel out this, so we have x as negative 2. So we have this set of possible zeros. Again, it's up to you if your technique is to simply transpose the value. For example, we have x minus 4 is equal to 0. If your technique is to transpose the value of negative 4, therefore it will become positive number. So therefore, it will give you x as positive 4. So that is okay. So for this concept, I use APE, okay, which is the legal concept in terms of isolating some values. Okay, so we have this value of 4 and negative 2 as zeros. That means the answer for this given problem, okay, since we're asked to find the zeros, we're asked to solve for the zeros of this given polynomial. Therefore, the values of x or zeros for this given problem is, so the first value is negative 1. Okay, we also have, according to our solution, we have 4 and negative 2. So the answer is this, negative 1, negative 2, and positive 4. So we have this final answer. Right? So again, that is our step to solve for the integral zeros of a polynomial function. Again, number 1 is we need to list all of the possible integral zeros, okay, with the use of our constant. Next, we need to solve at least one zero. So we need to pick at least one pair, okay, of possible integral zeros and use synthetic division or evaluation. For example, we have this problem. Okay, so according to this example, we have negative 1 and it will give us a remainder which is 0. That means this negative 1 is part of our zeros or solution. And then this negative 1, let's convert this into a binomial. Negative 1 as x is also known as x plus 1 into x minus c form, right? That means it will give us our factor. Since we have this quotient, it will give us this. Okay, we have x plus 1 times our quotient, which is x squared minus 2x minus 8. And then with use of this expression, for step number 3, we need to solve for the remaining zeros. So for the remaining zeros, it's up to you, since that is under quadratic expression or equation. So you are allowed to use at least 4 methods. Number 1 is it's either through factoring, completing the square, extracting the square root, or quadratic formula, right? So for this given problem, we use factoring. So we factor out this given example, and we have this final answer or roots as 4 and negative 2. And our last step, for step number 4, we need to list down our answer. So therefore, the values of the zeros of this given problem, so we have this answer, wherein we have x as negative 1, negative 2, and positive 4. Okay, so that is our step. So let's try to answer another set of problem. Okay, so for example number 2, let's say we are asked to solve for the zeros of this given problem. Okay, let's say we have p of x, let's say that is equals to x cubed plus 8x squared plus 11x minus 20. Right? Since we have this given problem, again, for step number 1 is we need to list down all of the possible integral zeros. Since we have this negative 20 as our constant, so let's use negative 20. Right? And let's try to identify its possible factors. So the factors of negative 20 is actually negative 20 times 1, or vice versa, okay, for its sign. We also have 4 times 5, also have 10 times 2, right? So 10 times 2 is 20, 4 times 7 is 20, 20 times 1 is 20. Right. So next is to list all of the possible factors. Okay, it's up to you. It's either in decreasing or increasing form. Let's list them. So we have 1, we have 2, also have 4, also have 5, also have 10, and 20. Okay. After that, since we have this possible of all, okay, we're looking for all possible integral zeros, we need to include also its positive and negative sign. So that means we have positive and negative 1, positive negative 2, and then the rest will follow. So if you want to count the possible zeros of this given problem, we have 2, 4, 6, 8, 10, 12. So we have 12 possible integral zeros of this given polynomial function. Okay, that's just step number 1. So for step number 2, so we need to pick at least one pair, right, of possible integral zeros for this given problem, and it's up to you if you want to use evaluation or synthetic division to solve for its quotient. Okay, so let's try to use let's try to use positive and negative 1. Okay, again, since we have this given problem, so I will rewrite our problem, that is x cubed plus 8x squared plus 11x minus 20. Right, so if we have this given value, let's try to use x as negative 1 and x as positive 1. Let's try to use synthetic division. Okay, so let's extract the roots of this given problem. Right, so since we have this given problem, the roots are, or the coefficient, we have x cubed, we have 1, we have 8 for x squared, we have 11 for 11x, and we have negative 20 for our constant. So I will copy the same values. Okay, so we have 1, 8, 11, and negative 20. So let's construct this bar. And we have this divisor as negative 1 and positive 1. And let's try to perform synthetic division. So same procedure, bring down the first number, multiply. 1 times negative 1 is 1, and then add. 8 plus 1, that is 9. Okay, so it will give us 9. 9 times negative 1 is negative 9, and then add again. So 11 plus negative 9, that is equals to positive 2. Right, so negative 1 times positive 2 is negative 2, and then add it again. So negative 20 minus or plus negative 2 is actually equals to negative 22. Since the remainder for this given problem is not equal to 0, that means this x as negative 1 is not a 0. Okay, it is not part of our solution. So let's try to solve or use x as positive 1. Right, so let's try to solve. So again, bring down 1, multiply. 1 times 1 is 1, and then add. 8 plus 1 is equals to 9. Okay, and multiply it again. 1 times 9 is 9, and then add. So we have 11 plus 9, right, that is 20, and 1 times 20 that is equals to positive 20, and then add. Negative 20 plus 20, that is equals to 0. Since the value of our remainder, or the last number for this given problem, is 0, that means this x as 1 is a 0. Alright? So, again, since that is a 0, it will give us this set of values. Okay? Since we have x as 1, if you want to convert x as 1 into a binomial form, that means this is equals to x minus 1. Okay, that is x minus 1. So let's try to list the final answer for this given problem. So again, this is our remainder. We have the constant, we have the first degree, and we also have the second degree. Okay, so the final answer for this given problem is we have x squared, or 1x squared, plus 9x and plus 20. So that is the final answer for this given problem. Okay, and again, this given expression together with x minus 1, or this value, will serve as the factor of our original problem. Okay, After that, since we have this first value or first factor, let's try to solve for um, the roots of this given problem, right? So let's try to solve for its roots. Again, since we have this given expression x squared plus 9x plus 20, okay? So again, since that is a quadratic equation or expression, so it's up to you. We have four methods to solve or to extract its roots. Number one is through factoring, completing the square, extracting the square root, or with the use of quadratic formula. So that is okay. So let's try to use factoring for this one, okay? So if you want to factor out this one, again, we need to think of two sets of numbers wherein if you multiply those numbers, it will give us the constant, okay? And if you add those numbers, it will give you the midterm or the linear term. So let's try to factor our first value or the constant, okay? Since that is 20, I think that is product of 20 times 1. Alright, so it's either 10 times 2, also have 4 times 5, right? So it's either positive or negative number. So let's try to multiply. So 20 times 1, so that is equals to 20, right? And 20 plus 1, that is equals to 21. Okay, so we have this 20, that is correct, to our constant, but if you add those numbers, it will give us 21. So it is not equal to our midterm. So we need to disregard our first factor. Okay, this is not part of our factor. Next, let's try to use 10 and 2. So 10 times 2, that is 20. Good, that is equal to our constant. But 10 plus 2 is equals to 12. It is not equal to our constant. So again, so that is not our factor. Next, let's try to multiply 4 times 5, that is 20. Okay, and 4 plus 5, that is equals to 9. So that means, since we have this value which is suitable to our given problem, the factors for this given problem is we have x plus 4 and x plus 5. Okay, so we have positive 4 and we have positive 5 as our factor. So let's try to, again, if we have this given set of factors, let's construct a t-table and let's extract their roots. So we have x plus 4, that is equal to 0. Let's equate all of those binomials into 0. So we have x plus 5 is equal to 0. And for the first value, since we have x plus 4, so let's subtract 4 both sides. Okay, so if your technique is to transpose the value of negative 4, it's up to you. Again, our goal for this one is to simply solve for the value of x. Okay, so I will use APE. So I will isolate the value of x. So I need to remove this positive 4. So I will add negative 4 both sides. Negative 4 to cancel out. That means x of 1 is equals to negative 4. Okay, next, if we have x plus 5 is equal to 0, so let's subtract 5 both sides, and then it will allow us to cancel this one. That means the value of x sub 2, or the second root, is negative 5. So we have negative 4 and negative 5 for this given problem. Okay, and step number 4, let's list down our list of our zeros. So we have, again, our first answer is positive 1, negative 4, and negative 5. Okay, so that means for this given problem, so I will zoom this one. So for this given problem, the zeros or the possible values of x are, again, we have 1, negative 4, and negative 5. And that is our final answer. Again, that's the concept of this topic named integral zeros of a polynomial function. So thank you so much and God bless.